All right. I guess we should start right now. And yeah, Vincent, feel free to admit anyone that uh, is going to join later. So, welcome everyone to the first session of the Unlock Xtreme 14 workshop series organized by the IEEE student branch. Uh, as you have already found out through the emails, the first workshop is going to be on the fundamentals of Python programming. Now, throughout the session, there will be some links shared. We'll make sure to share all the links in the Zoom chat. But if you would like to access the slides of this presentation, to feel free to move to the previous slide or the next slide uh, and if it was needed for you to check the previous slide, you could find the lecture at the QR code here. Uh, Vincent can also send a link of the slides in the chat for you to find out. So to give you an overview of what we're going to do today, the session is going to be organized into three sections. In the first section, we're going to have a sort of introduction or tutorial lecture on the fundamentals of Python programming, throughout which we will cover the basics of how you can code with Python. And in the second section, it will be followed by a live coding session and sort of like a live troubleshooting where we will send you some links to programming questions that we can solve together. And through this, we can see if there's anything needed to cover, and it's sort of a live practice of programming. And finally, since all these workshops are in preparation of the IEEE Xtreme programming contests, the final part of the final section of the talk will be a simulation of a live coding quiz. Now, I would like to let you know that all the uh, tutorial will be recorded and made available online in our YouTube channel. And as well as that, I wanted to let you know that there will be coding prizes and vouchers for students who are most engaging. So especially through the second and third part of the talk and webinar, it's going to be sort of a live session where everyone is going to be engaging, and there are vouchers and prizes made for that. And people who are winning the prizes will be contacted by IEEE with regards to that. So now that we have the overview aside, let's start with an introduction. So as I said, we are going to have an introduction to computer programming using Python language. Now, probably most of you know that Python is a popular programming language that is used a lot these days. It's used in web development, data analysis, machine learning, and research a lot. So what can Python do? Just to give you a brief introduction, it can be used as a web server. It can run scripts for automation and creating workflows for whatever you want to do in your PC. It can connect to and manage databases if you'd like to do database management. It can read, write, and modify files. It can handle big data, which is one of the things that is commonly used for these days. It's big data and complex data analysis. And it can compute and perform complex math, perform data analysis, and it's also really good for rapid software development and software prototyping, which is something that is really needed in research. So when you're on a research setting, you don't really want to create the best and the most efficient application, but you just want to create a prototype and see if your idea works in practice, and Python is really good for that. So the first question that you might ask is, why Python? And the reason many people recommend Python as a programming language is that, first of all, it works on many different platforms. You can run Python in Windows, Linux, and Mac computers. It has a simple syntax that is very similar to English language, so the learning curve is steeper, so you'll learn faster how to code in Python, and it lets the programmer write programs with fewer lines of code, which is really important. So normally, as an example, people say that if you were to write a simple task in C that would take 30 to 50 lines of code, you might actually be able to do it in Python with less than 5 lines of code. So it is really efficient for the programmer. It is, as I mentioned, quick for prototyping. It's a flexible language, so it can be used in many ways. So there are two different versions of Python available, Python 3 and Python 2. Python 3 is the latest version, even though lots of people still use Python 2. Python 3 is the common version to choose, and we'll be using Python 3 throughout this tutorial. Uh, for this tutorial, we've made an online there are different ways you could run Python on your computer. If you like to install, if you've already installed Python and you like to follow this tutorial using the Python version that you've installed on your system, you can do this, but you don't need to have Python installed to be able to work on the tutorial with us. All we need to do is there's an online link that we will be sharing, which has a online compiler of Python. So you'll just write it in a web page and it will execute. And for those of you who are going to be working with Python for a long term, I strongly recommend that you choose an IDE that is going to help with long-term using of a programming language by providing you autocomplete and sort of linting and even compiling and executing abilities in their framework. Some of the examples of these IDEs are PyCharm, Funny, and Eclipse. So as I mentioned, throughout this session, all you need to do is use the link provided here in the session. So the link is repl.it/languages/Python3. And once you open this web page, you'll have access to basically you'll have access to uh, a web page that you can run Python code inside. It might be slower than running Python on your own computer, but the plus side is that you don't have to install anything. So normally, it's common practice that whenever you want to start programming in a language, you start with this function called printing hello world. So the first step of programming would be you'd start printing something on the screen. And just to give you a little idea of how this would work using this online setting, you will be having two windows here. On the right side, you'll have something which is called the Python console. So in the Python console, you write a line of code and it executes right away. You also have a simulated file on the left, so this white piece of script here. In this piece of script, you can write multiple lines of code, and once you hit run, it's going to execute in the terminal. So basically, to practice this, as we saw here, the very first command that we wanted to use was the hello world. And to have the hello world, the command to print something on the screen using Python is simply print, open parentheses and close parentheses, and you just put whatever you want to print on the screen in between. And so we can see that using this platform, for example, I could use the console and type print hello world. And as soon as I hit enter, what happens is that the console will read the line of code that I wrote, execute it, and we can see that the console is going to write hello world out in the screen. Now, as I mentioned, the other alternative would be to write it in the file. So you could write the very same thing here. And so in here, you could write multiple lines of code. And once you hit run, the server will execute all the lines of code that you've written, and you'll see the output on the right. So if instead of having one line of code printing hello world, I had multiple lines here and I hit run, the server is going to run all these lines one by one and print multiple times hello world on the screen. So throughout the session, you will be able to run these codes using that online system. And whenever needed, I'll also try to run the codes with you throughout the tutorial, but just to make it faster, I won't write all the codes in the tutorial. And I'll just have the scripts here, and you can, using the link, you can try them out and see how it feels to run a piece of code using this online system. So now, so far we know how to print something in the terminal. So this is called how you, in programming, this is called generating an output and printing an output to terminal. Now, the other concept that we might want to do is read input from the user. So let's say you want to write a program that asks someone how old they are. So the first thing that you need to do is to get some information from the user. And the way you do it in Python is with the command input. So input, open parentheses and close parentheses, is going to give the user the opportunity to send us some information. And just to showcase this as well, if I were to use the console and I would only write input, open parentheses and close parentheses, as soon as I hit enter, we can see that the console terminal is waiting for us to give it some input. So you could say hi, and as soon as we write and press enter, our input is going to be then sent to Python, and that's why Python is reprinting this. And it's good to know that the thing with programming languages is that you combine all these knowledge, so the different functions that you know how to use to write a piece of code that does something complex. So far we've learned the commands print and input. So what we could do is we could read something from the user side and print it in the terminal. So what we're doing is we're using input command to get user input, and then we're using the print method or the print function to print whatever we got. So if I press enter, right now it's waiting for me to provide something. So if I say hello and then press enter, we can see that, so the first hello is something that I wrote and I sent it to Python as an input. And the second hello is the print function then printing my input in the screen. All right. So one of the advantages or one of the points that you need to know regarding the command input is that you could also provide a piece of text to inform the user what sort of information you're demanding from them. So for example, in this simple piece of code here, we're saying input, and then in the parentheses, we're asking the user to enter a username. So if we execute this command, so if we execute this first line of the command in terminal, so in this first line of command, what we're doing is we're asking the user to input something, and we're telling them the information that we want it to be a username. And then we're saving it in something that we call variables. We'll cover this in the next slide, but we'll save the user input in a variable. So as soon as I hit enter, we can see that the computer first shows this message that we want the user to see. So enter username, and I can, for example, say username is Sina, and as soon as I enter, the code execution is finished, and what has happened behind the curtains is that whatever I wrote is now saved in the variable username. So if I were to basically print the username, it will print Sina. So this is how you could save a variable using the input command. So take an input from the user and then retrieve it at some later stage in the later lines of your code. All right. So now that we know how to read an input and write the write outputs to the screen, the next thing that is really good to know about programming is how do we add comments. Now, what are comments? So, as I mentioned before, every line of code that you write, as soon as you hit enter, the computer starts reading it and starts processing it to understand what it needs to do for you. So you're telling the computer what to do for you. But sometimes you need to have some information in your code that is not for the computer to know, it's just for you to remember or for someone else that's going to read your code later to understand what your code does. And these pieces of information that the computer is not supposed to execute are called comments. So in Python, you could use this character hashtag to start writing a comment. So if I start a line by hashtag, as soon as the computer reads this hashtag sign, the computer knows that it doesn't need to do anything with whatever follows. So I can write hashtag and then say, okay, I'm going to store username from the user input. The computer is going to read this line, but it's not going to do anything. Now, in the second line doesn't have a hashtag, so the computer knows that it has to take an input from the user and save it in the variable called username. And then again, I have another comment here. I just want to let myself know that the following line is going to print the stored username. So comments are really useful, and it's a good coding practice to do, especially if you're coding for a large project, to write as much informative comments that you can so that other people reading your code, or even you reading your code 3 months later, could understand what's happening with your code. Now, Python also gives you the possibility of writing multi-line comments. So if you want to write something in multiple lines, you could either put a hashtag sign at the beginning of each line, or you could put 3 double quotation marks, hit enter, and write whatever you want to write, and then end it with another 3 quotation marks. And Python is going to understand that whatever is in between these 2 lines is going to be a large comment, so Python doesn't need to execute it. So a piece of code that we did see earlier, but we didn't pay much attention to it, was this first piece of the code. So we wrote username is equal to something, and this is called variable assignment. So in order to use Python programming language to do complex stuff, you will need to store stuff in the memory. And the way you store something in the memory is that you will link it with a name that you can call later. So if I want to store the user input, I will use a variable. So I'll define a variable. This is totally my choice. I wanted to call it username. I define the variable name. And then after that, the equal sign here is the assignment operation. So I tell the computer that whatever is on the right side, compute it and then store it in my variable on the left side. So it is important to use variables to store whatever you want, and this is one of the key pieces of the programming concept that gives you the ability to write complex pieces of software. Now, as I mentioned, you could assign variables using the equal sign, and you could, for example, store different variables with different names, and later in later lines, you could then call those variable names, and the programming language has already saved that variable name somewhere and can access it later. For example, here, we saved the number 5 in a variable called x, and a string Sina in a variable called y. So later in the code, when the computer reaches a line and we ask the computer to print x, Python knows that we have already saved 5 in x. So once we run this code and reach the line that we're going to print x, we can see that in the output, it's going to print 5. I'm not going to execute this in the terminal myself, but you feel free to run this in your terminal and see that when you run print x, it's going to print 5, and when you run print y, it's going to print whatever the string you put here. Okay, so in the previous slides, we saw that we can have different data types. So it could be a number that we want to store in a variable. It could be a set of characters that we want to store in a variable. And in Python, these different types of variables that we can store are called Python data types. Now I want to bring into attention a set of main important data types of Python. So as we saw in the very beginning, we can store text using a variable, and this variable is called a string, and it's defined by the symbol str in the Python programming language. And the way we provide strings to the Python language is through double or single quotation marks. There's no difference between double or single. So if we write x equals double quotation, something double quotation, all that goes in between is going to be one string variable stored in x. Python also has other data types. Some data types that are really useful are the ones that we can save numbers inside. So we could store integers, floating numbers, and even complex numbers using these data types. And another data type that is also really useful in programming are the Boolean data types. So Boolean data types are variables that can only have two values. These variables are either true or false, or the way programming the way in programming we like to say, it's either 1 or 0. And that's why they say computers work with 0 and 1. Basically, all computer code is generated using Boolean signals. And this Boolean data type, which stores either true or false, 1 or 0, is really helpful in programming. Now, as I mentioned, Python sort of is kind of smart to figure out what the data type of the variable that we are saving is. So when we write x equals 5, Python figures out that this variable x is going to be having a data type of integer to be able to save this value. Some other programming languages don't provide that. So every time you want to define a variable, you have to mention that this variable is going to be an integer, or this variable is going to be a string. But in Python, Python takes care of that for you, so you don't need to mention that I want to store this variable as this type. And then Python has this function called type, which if you use, you can see the type of different variables. So if I run this piece of code in my terminal, I can see that when I print type of x, Python is going to tell me that x is of type integer or int. Now, a useful command in programming is variable casting. So sometimes you want to enforce a variable to be of a certain type. You want to make sure that your variable, for example, is an integer, is a floating value, or a string. Now, in order for Python to understand this concept, it uses something called variable casting. So if you want to save something and you want to make sure that it's an integer, you'll use the function int, open parentheses, close parentheses. So here's an example that we have. So if we want to store a variable and we want to make sure that it's being stored as an integer, we'll provide the function int, open parentheses, close parentheses. So if in here, we have three different examples. If you write the first example in the terminal, you can see that when you store a value that is an integer and you provide this casting function, x is going to be stored 1. But if for some reason the variable that you're storing isn't actually an integer, so let's say we want to store 2.8, but we want to make sure that what we're saving is going to be an integer, this casting variable makes sure that it's going to happen. And the way Python does it is that if you try to save a floating point variable, so 2.8, as an integer, what it does is that it will remove everything that's happening after the floating point, and y will only be 2. Similarly, you can use this casting variable function to save a string as an integer. So we can see that if we provide a string into the function as an input, So this is something that I guess it's good to mention. Whatever we put in between the parentheses is going to be the input of a function. So the way Python works with functions is that you will first have the function name, open parentheses, the input that the function takes, and then close parentheses. And a function is basically a black box that you will provide some input to it, and it will give you some output. So in here, we can look at this casting function, this casting idea as a function that takes an input of any type possible and tries to make it into the type that you mentioned. So it tries to generate an output that is an integer in this example. So if we provide a string and save it in Z as an integer, we can, by printing the type of Z, we can see that first of all, Z is an integer, and second, it's the value 3. You could do the same idea of casting for floats. So if you store an integer as a float, it's gonna make sure that it has converted it to a float. You can save a float as a float, or you could also save strings as a float. Very similarly, you might want to save something and make sure that it's going to be a string. So you could use the casting function str to make sure that your variable is going to be turned into a string variable. Now, let's see a sample application of casting. So what I'm going to do is I'm going to copy this piece of code from here, and let's try executing this together. So what I'm going to do is I'm going to go through this example line by line and see what's happening in this piece of code. So I'm just commenting this, the second and third lines of code, and I'm going to look at the first line. So in the first line, I'm creating a variable called birth year, and what I'm going to do is I'm going to store an integer in that variable. Now, what is that integer going to be? So whatever in between these parentheses is the input function, the input of the casting function int. And what I'm going to do here is I'm going to take an input from the user. I'm going to ask, what year were you born? And whatever information the user passes to me, I'm going to treat it as an integer and save it in the variable called birth year. So if you remember, the command input was used to save something that the user has provided, but you need to note that this command saves whatever the user provides as a string, because it's something that you type in your computer. The computer, Python assumes that it's going to be a string. So if you know that you want to take a number from the user, and you're sure that the user is going to provide a number, you'll have to convert or cast it into a variable of type integer. Now, once this variable is stored in this variable called birth year, what we then can do is to run an arithmetic operation. So let's say we want to take someone's birth year and compute their age. So all we need to do is to subtract the birth year from 2020, and we'll have the user's age. So if we were to print you should be age now, it's going to print for us the age of the user that has provided the input. And you also should note that in here, since we want to print something, we would like it to be a string. So we're casting the variable age, which is of type int, back to a string so that we can print it for the computer through the computer terminal. So if I were to run this, we can see that the computer is first asking, what year were you born? So let's say, I don't know, 1999, and then hit enter. So as soon as I hit enter, it executes the next two lines, and it tells the user that, okay, you should be 21 now. So that is an example of how you can use variable casting to write a piece of code that is a little bit more complex. So I can see that someone has asked that can we also print an int? So yes, Python does give you the ability to print an int. but we will get back to this issue of what you need to do. So in here, the reason we had to make it back to a string is because we want to do some string operations. So we want to concatenate two strings. And for us to be able to concatenate two strings, we need to make sure that they both are strings. So if we wanted to say only print age, we could have said print open parentheses age close parentheses, and the computer would have understood that even though age is an integer, it would convert it to a string and then print it. Okay, so to have a closer look at different data types that we've talked about, especially the basic data types, one of the very basic data types is a string. And what a string is in Python language, it's basically storing an order list of characters. So when I say list, what I mean is that it can have multiple characters, and a string can have even no characters. So you can have open quotation, close quotation without anything in between, and that will be an empty string. So that's why we call it a list. It can have anywhere from 0 to as much as you want characters, and it's also ordered. And what we mean by ordered is that we can index it. So we can say this is the first character of the string, this is the second character, this is the third, and so on. So in order to tell the computer that something that we're writing is a string, all we need to do is to put double quotations or single quotations around it. Now, in some programming languages, you only have the option of using one of these formats, but Python treats both stuff that are put between double quotations or stuff that are put between single quotations as a string. Now, as I said, we could tell Python to store this string that we write, so hello, in a variable a. And if we were to print a, Python would understand it to print hello. But also, you could store a string that is longer than one line. So if you wanted to store a string that is a long string, so it's not going to fit in one single line, what you're going to do is you could provide, again, 3 double quotations, and that's going to start a multi-line string assignment, and you'll write whatever you want, and Python will read the following lines until it reaches another sets of 3 double quotations, and Python will understand that whatever is inside the two, the starting and end point, this is going to be one long string. So if you were to print a, it would print everything that is between the 3 double quotations here and here. Now, one of the advantages of saving something as a string, as I said, is since it's an ordered list, we could index to it. So let's actually try this again together. So if I were to save a variable, the variable is a string, hello world, in A. Now we can see that if I were to print A, it would print hello world. But as I said, since this is an ordered list, I can index it. So tell it to only print a specific part of A, let's say. So I can say A1, and let's see what that prints. So it prints E. So this might be a little bit unexpected for you, but Python, much like a lot of other programming applications, is a language that starts the indexing from 0. So we would say that H is the 0th element of this list. E is the first, L is the second, and so on. So if I wanted to, in English language, if I wanted to actually print the first character of this string, I should have said print A0, and then it would have print H for me. So we can index through a string using open and close brackets. So using square brackets, as shown here, we can only print a single character from the string A. And there are also other ways of referring to a part of the string. So we can use colons to to take information of a subset of the whole string. So what we want to print here is we saved hello world in B, and when we say print B 2 semicolon 5 close brackets, what Python is going to do is it's going to start from the second element. So it would be, so H is 0, E is 1, and this L is element number 2, and it will print up to element number 5. So it will print L, L, O, and then stop. So that's how you can refer to a slice of the string. And another point to mention is that Python also gives you the ability to index a string from the end of it. So, and the way you do it is with negative indexes. So an index of -1 would mean the last element in the list. So since the string is similar to a list, the last element of the string can be referred to be -1. And so in here, we can have a slice from the end of the string. So we will say start from 5 words before the end. So it's going to be O, and then print it up till the second last word, which is D. So it's going to print this part. So someone's asking in the comments what's going to happen if we print from 2 to 6. So we have A here. Let's actually try this together. So if we were to print A from 2 to 6, it will, so the 6th element would be comma. So it will start from the element number 2, which is L, print 2, 3, 4, and 5, but not 6 itself. Actually, since 6 might be the space, let me try this with 7, just to make sure. Yep, so it will print up till, but not the last element. So if I were to print from 2 to 3, it will only print one element. So when you're slicing, the first element that you provide is going to be inclusive, but the last one won't. So it will include the element number 2, but will not include the element number 3. And yeah, something else that we need to know is that, so if we put 10 here, Python, it's even longer than 10 words. I didn't understand that. Oh, let me see. If we put 100 here, Python understands that 100 is longer than the length of the string, and it is going to correct our error. So it will not cause an error if we say we want to print A from 2 to 100. It will just print from 2 to the end of the list. In fact, if we even don't provide anything here, so if we say 2 semicolon and then nothing and close the brackets, and we print it, it's going to print from the element number 2 to the end of the list. And also another useful function whenever we have something that is list-like in programming is we want to know the length of the list. And the function that gives us this ability in Python is the function len. So if we print len, open parentheses, b, close parentheses, it's going to print the number of characters that is stored in this string. Now, I just wanted to quickly cover a set of functions that you could use for string data types. So first of all, if you have a string data type that has a white space around it, you could use the strip function to remove this white space around it. So if you have spaces, new lines, it will remove all of them. So if you do a.strip, it's going to run the strip function on the variable a, and it's going to remove whatever white space that you have before and after it. The other useful functions that we have are lower and upper. And what it's going to do is it's going to turn everything to a lowercase character or turn everything to an uppercase character. And another useful function is the replace function. Now, when you call the replace function on a string variable, what it does is it is going to take in two inputs. It's trying to find the first input throughout the variable and replace it by the second one. So if I call the function that's going to replace all the L's with the character J, and I give hello world as an input, this is what's going to be the output of the code. So it's going to replace all L's with J's. Another useful command when working with the strings is the split command. What the split command does is it breaks a string into a list of shorter strings using a delimiter. So if we want to, let's say we have a comma separated input from the user and we want to separate it, all we need to do is to call a.split. And it's going to return to us a list of strings that is being split by the comma. So the comma itself will not be present anymore. And the first part is going to be hello, the second part is going to be space, and followed by world. Another useful function when we're using strings is to see if a pattern is actually existing in a string. So for example, we have a string saved in the variable a, which is hello world, and we want to see if the substring ELLO exists in that original string. What Python offers to do this is the command in. So you could write LO in A, and Python will look for occurrences of ELLO in the original string. And if this thing on the left-hand side of in exists in whatever is in the right-hand side, Python is going to tell you that yes, it is existing. So X is going to be true. So X is a Boolean variable, and it's going to be having the value of true. Sorry. And similarly, if we look for a pattern that does not exist in the original string, it's going to return false. So if we search for ALLO, X is going to be false. So the next cool thing with strings is using arithmetics to concatenate strings. So let's say you stored a string called hello, another string which is stored the string world. You could use the plus sign to concatenate the two. So you could say a plus b, and it's going to compute hello added world added to the end of hello, so hello world. You could also add a space in between, and then this new variable is going to be hello space world. So another useful thing that we've also seen in our printing age example is we sometimes want to print something that is not an integer, that is not a string within a string. So the way we did it originally was we would say, we would use these plus signs, which we now know are for concatenation of strings. And then whenever we want to use something that is not a string, we would just cast it to a string. So if I wanted to print, I have 5 apples, what I would do is I would write, I have plus the string of 5 plus apples. But Python actually provides us easier ways to do this. And this is called string formatting. So we write a string and we use curly braces to tell Python that I'm going to replace here with a variable. So I'm sorry. Yep. So for example, if I wanted to replace the variable 5 in the string, I would say print I have X apples and use these curly braces, and it will print 5. Now, there are some special string characters that are existing. So, for example, if you wanted to have a string and store a single quotation mark or a double quotation mark in the character, what we can do is called character escaping. So we use a backslash followed by a single quotation or a double quotation to sort of save these variables in a string. Now, another data type that we have is, as I said, Booleans, and Boolean is going to be either true or false. Now, here I have a few examples of how Booleans could be helpful. For example, you could compare two variables that you've saved earlier. So if you have two integers saved, you can compare and see if the first integer is very similar to the second integer. And you could also compare whether one is smaller than the other or one is greater than the other. And it's going to be saved as a variable which is either true or false. And you can then use this in coding to do more complicated stuff. You could also see if two things are not equal with exclamation mark equal. You could see if something is lesser or equal to something else. And you could also see if something is greater or equal. All right. So I would like to talk a little bit about different operators that you can use in Python programming language, some of which that we have already seen. So we've seen that you could add two numbers with the addition operator. So for the data types that are numeral data, we could use the plus sign for addition, the negative sign for subtraction, so this star sign for multiplication, so 2 times 2 is 4, and the slash sign for divisions. There are also 3 other arithmetic operators that Python has. The first one is modulus. So you want to see what's going to be the remainder of a division. So you can say divide x by y and tell me what's the remainder going to be. Double stars, it's going to be used as exponential, so x to the power of y. And you could also use double divisions to have a floor division. So divide x by y, but ignore whatever is after the floating point and just return an integer. Now, another set of operators that we have are assignment operators. The very first one we already seen an example of, which is the equal sign. The assignment operators are going to be used to save a variable or to modify an existing variable. So the equal sign saves a variable, but there are also, you could also combine the equal sign with the arithmetics that we had previously seen to have a different type of assignment, which is, so when I say x plus equal 10, what Python is going to do is it's going to add 10 to the existing value of x. So x equals x plus 10 is going to turn into, so if x was originally 10, after running this line of code, x would be 20. Now, as I mentioned, there are also some operators for comparison. These operators are going to result in a Boolean, so you can see if two things are equal, not equal, and if something is greater or lesser than the other. There are also 3 logical operators that can be used for Boolean data. Now, these 3 logical operators are AND, OR, and NOT. You can use AND, OR, and NOT in Python to combine the result of a logical operation, so combine the result of a set of Booleans. So if you say A and B, and notice A and B both need to be Booleans, it will only be true if both A and B are true. You could similarly use A or B, and it will be true if either one, A or B, is true. And finally, you could use not operator to reverse. So if something is true, it's going to become false, and if something is false, it's going to become true. Now, there are also some other operators, but are not used as much. And these operators are basically because Python wants to be human readable. For example, there's the operator is and is not. which is very equal to uh, uh, checking if two things are equal or not equal. And there's also in and not in, which we've seen in the example of strings, that we can check if something is part of something else. So if X is in Y, it means that it's part of Y. Now, in this next part of the talk, which is going to become a little bit of live coding soon, we'll be covering other complex data types, so lists, tuples, and sets together, and see how we could use these more complicated data types in a few examples. So these data types can be used to save a collection of items. For example, lists, as we've seen earlier, we mentioned that a string is similar to a list for characters. Now, originally, a list is something that we save using open brackets, followed by a collection of items and close brackets. So if we say this list equals to apple, banana, and cherry, and we print a list, Python is going to know that it has 3 elements. It's a collection of 3 elements, apple, banana, and cherry, 3 strings. Now, similar to strings themselves, for any list that we have, there are a set of functions that we could do. So we could index through a list. For example, we could only print this list, the element 1 of the list, which is going to be 0, 1, banana. So when we execute print this list 1, it's going to print banana. We can index it using a negative index. So if we print this list -1, it's going to start from the end of the list and print mango. We can also use a slice of the list and print that slice of the list. Additionally, we can change a value in a list. So we can see that this list 1 used to be banana, but we can say this list 1 equal to black currant, and we're going to assign a new value to the second element of the list. And once we print it, we can see that banana is replaced with black currant. We can also, as I mentioned, use the in command to check if an element is in the collection. So we can see if cherry is in the list. And this is going to be true because it is, and pear is not on the list, so it's going to be false. We could also check the length of a list, similar to the way we check the length of a string. So if our list of fruits have 7 different fruits, once we print it, it's going to print 7. We can also add a new item to an existing list using the command append. So here we add orange to the list, so the list is going to be updated with orange added to the list. We could also use the command insert to insert the new item in a specific point in the collection. So if we wanted to insert orange to be the second element of the list, we would say insert and then put the number 1, and it will insert it at the right index. So it will be apple, orange, banana, the order. We could also remove an element from the list using the remove function. So if we say this list dot remove orange, it's going to remove orange from the list. We could also use this list dot pop, and this will remove the last element of the list. So in this case, it will remove cherry. We could also use the del command to basically delete an element, similar to remove. And we could also use the command clear to remove all items inside the list. Now, I need to point this out that unlike numbers, we cannot copy a list by a simple assignment. So if we say list 1 is equal to list 2, so put list 1 and list 2, it's not going to create a copy of list 1. It is just going to be a reference to the same variable, to the same list. And Python has a different command to create a copy of a list. So if we want to copy this list to a new variable that has the same list, a replica of the same list, we should use the function .copy to create this copy. And then if we do print my list, it's going to print it. As an alternative, we could use the list casting function. So if we say my list is a list of this list, it's also going to create a copy. We can also join two lists with the concatenation idea that we've seen for strings. So if we have two lists and we concatenate them using plus, these lists are going to be joined together. Another data type, much like lists but a little bit different, are tuples. The only difference with a tuple compared to a list is that a tuple cannot be modified after creation. So we can create a tuple, we can print them, we can see if something is inside a tuple, we can see the length, but we cannot modify it. So if we were to change cherry to orange, it will cause an error. We could also join tuples together, very similar to a list. Now, why would someone use tuples? As we've seen, it's just so restricting not to be able to modify stuff. So the reason there are a few cases where you would use tuples commonly. One is for a multiple assignment. So if you want to create two variables simultaneously in one line, you could use the idea of tuples by separating variable names with a comma and then assigning multiple values to them using a multiple assignment. It could also be used to swap variables. So if you have A and B, but you want their values to be swapped, what you can do in one line is you could write A comma B equals B comma A, and it will swap it. And it's also used in writing methods and functions to return multiple values. So that's basically the main use cases of tuples. Another complex data type used to store collections of stuff are sets. And the difference of sets to lists is that sets are not ordered and can only have one of a thing. So there can't be a duplicate in a set. So we can have a set of apple, banana, and cherry, but we cannot have a duplicate. So we cannot say apple, banana, cherry, and then another banana. That will raise an error. So a set is really good if you want to use this command, the in command. It is really efficient to check if something is in your set. So if you're having a set and you want to check if something is in your set, if you have a collection and you want to see if something is in your collection and you want to do it in an efficient way, a set is what you would use. Now, in order to add something to your set, you would use the add function. In order to remove it, you would use the update. In order to add multiple things at the same time, you would use the update function. And similarly, you can see the length of a set. You could also remove something from a set using. So someone has asked if you can copy a list as a set and to get all unique values. Yes, you can. And what you need to do to convert a list to a set is basically variable casting. So if you have a variable that is a list, if you cast it to a set, so set open parentheses, your variable, which is a list, and then close parentheses, it's going to convert it to a set and remove the duplicates. That's actually a common approach used to create sets from already existing lists. Then also you could remove stuff from your set. You could use the remove function, but you should note that if that element is missing, you're going to get an error. Alternatively, you could use the discard function. This will not give you an error if the element is missing. And you could also use the clear function to remove all the items. You can use the union function to combine two sets together, so it will combine them and make sure to remove all the duplicates. Now, so I think this is the last complex data type that we're going to talk about, and it's a really useful data type in Python, which is called a dictionary. And what you do in a dictionary is that you can save key value pairs. Okay, I've just been noted that well, we're getting a little bit out of time, so I guess what we're going to do, I'll try my best to wrap up this lecture quickly, and then we can start the live sessions, and throughout the live sessions, practice these ideas more sort of coding together. Okay, so just to go over it really fast, dictionaries can be used to store key value pairs. So here's an example. You can save a variable and say, okay, I have a key brand and the value for it is Ford. I have a key model and the value for it is Mustang. And I have a key year and the value for it is 1964. So I'm basically saving a bunch of information, in this case, about a car in a single variable, which is a dictionary. Now, the reason that we use these dictionaries is that then we can find the values as assigned to these keys really quickly. So we can say, from my dictionary, retrieve the value model, retrieve the key, the value for the key model, and it's gonna, so if we see here, we have the model Mustang, so it's gonna retrieve Mustang. But you should note that if we use this way of indexing to a dictionary, and if this key is missing, it's going to cause an error. There is a function to avoid getting that error, and is the get function. So if you use get this key from my dictionary, it's going to look through the dictionary and see if this key is existing. If it is existing, it will return the value of that key. And finally, you can use this very function to also set a default value. So basically, search in my dictionary, see if I have a key called model. If I have it, return the value of the model. If not, just return a string called unknown, so that I will know that the model is unknown. Okay, so similar to the other data types, you could update a dictionary. You could use the function keys to see the list of keys existing in a dictionary. You could use the function values to see the list of values stored in a dictionary. You could use the command in to see if a key is existing in your dictionary. And you could also use the command len to see the number of keys stored in your dictionary. You could add a new item to a dictionary using this syntax. You could remove an item from the dictionary using the function pop or using the command del. And you could clear all the things stored in a dictionary using the function clear. Okay, so similarly, you can copy a dictionary using the command copy or by casting an existing dictionary to a new dictionary. You should also note that you can have nested dictionaries, and this is an idea that you can use to sort of build more complicated stuff with programming. So for example, you could have a dictionary of a family that has 3 childs, and for each child, you have the name and the birth year of that child, and then you could retrieve this information with multiple indexing. So you would index through the family, get the second child, and then index to the second child and get the name. Okay, so far, whatever we talked about, the code execution that we had in Python and the way we described it was line by line. So the computer reads the first line, it executes it, reads the second line, executes the second, and so on and so forth. But actually, what makes programming more interesting is that we could create branches and we could sort of create new conditions, and that's how we can solve puzzles. For example, a concept that is really useful is conditionals. And this, in using conditionals, you can tell the code to do something only if something happens. So check their age. If they're over 18, tell them that they can come to the restaurant. If not, tell them to leave. So this is how you could use conditionals in Python. You would write if, you then provide a conditional. So in here we can say if B is greater than A, you then put two colons. And the way Python understands that you're inside the function is using indentation. So we have put two spaces here. You could choose whatever indentation that you like. Two spaces is one of the common things that is used in Python. Some other people use four spaces. As long as it's consistent throughout your code, it's fine. So you can tell Python if the two variables that I've saved, if b is greater than a, come inside this indentation. So look for everything that is two spaces ahead and execute whatever is inside. And obviously you could have branches. So if b is greater than a, I want you to print something. Notice the indentation after the if, and then using the command elif, I want to give you another conditional. So if a is equal to b, I want you to print a and b are equal. And then you could also have further branching. So you could have multiple, so you can have an if followed by multiple elifs, and then end by else. So if none of the conditions through an if is met, Python is going to run whatever is following the else. So else print a is greater than b. So this is, the conditionals are a really useful concept for programming. And I guess you're going to use it a lot once you start solving puzzles. And one of the benefits of Python is that you could, as I said, write all of this in a single line if you want to. So if you write if a is greater than b, colon, print something, Python will understand. And this will only work if you have a single command to execute after the conditional. There's also a different form of it which is more human readable. So you could say print a if a is bigger than b, else print b. And this is also going to work in Python. So this is an alternate syntax of printing, of writing conditionals in Python. And you could also combine conditionals with logical operators. So you could have multiple conditions if both of them or either of them, so using and or commands, you could create a more complex conditional. And if all this, all of it is going to result to true, whatever follows after is going to be executed. And also another idea that you could have is to have multiple conditionals nested. So you'd have the condition 1. If condition 1 is met, notice that everything after this line, since everything is executing within this if conditional, it's all indented with two spaces. So if x is greater than 10, do all that follows. Now I have another nested conditional. So if x is greater than 20, I do another indentation, and then I ask it to print and also above 20. Okay, so the pieces of the puzzle for programming are nearly complete. The last thing that we would know in order to be able to make what we want using programming is the idea of loops. And loops is basically telling you, what if you wanted to execute a single line of code multiple times? For example, what if you wanted to print it the same thing 10 times? One way to do it is to write the print command 10 times, but we can see that it's not scalable. So there's the concept of loops that with this concept, you iterate and do something over and over. So there are two different ways to have a loop in Python. The first one is using the while command. The logic is this way. You check if a statement is true or false. And as long as that statement is true, you keep doing something. And once that statement is no longer true, you will continue reading the next lines followed. For example, if let's imagine we want to write a code that tells the computer to clean all the apples in the basket. The way we can tell the computer to do this is we can tell it, okay, check in the basket, see if there are any apples in the basket. And as long as there are apples in the basket, clean them and put them aside. And this is basically what a while loop does. Now, this is an example of a while loop. So how you write a while loop in Python. So we have a variable and one is assigned to this variable called I, and we are asking Python, check and see if I is smaller than 6. And as long as I is smaller than 6, print it and increment it by 1. So it's going to print 1, increment it to 2, print 2, then print 3, then print 4. So it's in the loop. It's going to print 1, 2, 3, 4, 5. And then once it reaches 6, it notices that I is no longer smaller than 6, so it will exit the loop. So if you run this piece of code, you will print 1 to 5. Now, there are two keywords that you could use within a while loop to further change the line of execution. The first command is break. Now, whenever Python reaches the command break, it's going to exit the loop, even though this condition is not met. So in here, we said if I is equal to 3, break. Now, once we run this, what's going to happen is that it's going to print 1, 2, and 3, but it's going to stop and not print 4 and 5. Another command is continue, and the continue command is going to just skip over that iteration of the while loop. So when we run this, we say if I is 3, continue. So it means that it's not going to print 3. So it's going to print 1, 2, not print 3 because it sees continue and passes over this iteration, and then print 4 and 5. Now, another very useful way of writing loops in Python is called the for loops. And this is basically helping us to write a loop, to loop in a set of collections. So let's say we have a list of names, and for each of them, we want to print it, for example. That's where a for loop would come in handy. So we'd say for any item in a collection, do a set of things that I'm telling you to do in the indented lines. So to have a very simple example of it, we have a list apple, banana, and cherry, and we can say for X in fruits, so for whatever fruits we have, just print them, and it's going to print their names separately. And you could also imagine that this is going to be used to on any other type of iterable. So if we have a string, since a string is a list of characters, if we were to write for X in banana, print X, it will be printing B in the first loop. Then it's going to print A, followed by N, A. So it will print every character in a single line. Similarly, it could be used to print, this idea of for can be used to loop inside a dictionary. This is a simple example of how to do that. And also similar to the while loop, you have the break command. So you could say for each fruit, print it. And once you reach banana, break. So this is going to print apple and banana, but not cherry, because break is going to stop the execution of the loop and go out. Similarly, you could use continue to just skip one iteration of the loop. So this command is going to print apple, it's going to skip over banana, and then print cherry. And finally, you can use this idea of a for loop with combined with a function called range to do something a multiple of times. So if we write for X in range 6, print X, it's going to iterate. So this range is basically a iterator concept. It's going to iterate over 0, 1, 2, 3, 4, 5, up till it reaches 6, and then stops, so comes out of the loop. You could also give it 2 numbers, and it works as indexing, so it will start from 2 and continue for 2, 3, 4, 5, and then step out of the range. So this is how to create a loop of any wanted range. And you could also even mention a third value, which is going to be the step size. So if you have a for loop with a range of 3 values, it's going to start from the first value. So start from 2 in every round, print the number as long as it's smaller than 30, and have a step size of 3. So what it is going to do is going to print 2, 5, 8, and continue. And once the number that is going to be, once the next number is out of this range, it's going to step out of the for loop. So whenever, as soon as it reaches 30 or above 30, it will stop. Now, another idea that obviously we could have is similar to while loops and similar to if statements, we could have nested for loops. So basically this function here is a for loop in the first list, is going to do a for loop in the first list. And in each iteration, it's going to do a for loop in the second list. And it's then going to print the combination. So if we do this, it's going to print red apple, red banana, red cherry, and then big apple, big banana, big cherry, and then finally tasty apple, tasty banana, tasty cherry. So you could have 2 for loops within each other. And finally, to help save space, another way to write less code is using functions. So you can write a function once and use it multiple times. For example, if I want to print hello from a function a multiple of times, I can write this simple syntax here. So I can define a function using the def command, followed by the function name, and then after the colon, with an indentation, multiple lines explaining what my function does. And as soon as I execute this, when I execute this, nothing is going to happen. But whenever I call my function, Python will know that I have previously defined a function and execute the function that I wrote. And what makes it even better is that your function, as I mentioned, can have an input. So I can have a function that gets a first name and then prints first name plus Jonas. So for example, if I wanted to print all the Jonas brother names, I would call my function 3 times with 3 different first names, and it will print it 3 times. My function can even have multiple inputs. So I could print and combine these multiple inputs into an output. And also something else that I think is important to be mentioned is that we can have a return value for a function. So if I have a function that takes x, and it can be a function that returns 5 times x. So whenever I print or wherever my call function later in my code, the function is going to do 5 multiplied by the input and provide it to the output. So print my function 3 is going to do 5 times 3 and return it. And then print is going to print 3 times 5, which is 15. And similarly, I can save this output in a variable. So I could say my function 5, it's going to compute 5 times 5, and then 25 is going to be stored in A. And needless to say, we could have conditionals within a function, and we could have even this, there's an idea of recursion. So we could have a function called within a function. So similar to the idea of nested ifs and nested for loops, we can have a function inside a function. But this is getting a little too complicated. All these examples were meant to tell you that when you're looking into programming, it's basically looking similar to looking at different pieces of Legos. And what makes it interesting is how you're going to combine these pieces of Legos together to create something fascinating. And that's why in this session, we would like to have a live coding practice through which we will try to solve a set of puzzles together and see if we can learn from each other. So as I mentioned in the emails earlier, you should have created an account in this website, www.hackerrank.com. If you have, what we're going to do right now is we're going to start with a very, very basic challenge, which is just printing hello world in the terminal. I will copy this link into the Zoom chat. So from now up till 6 o'clock, let's say, we will try to see if in a live coding session we can solve a set of puzzles together. And after familiarizing ourselves with this platform and HackerRank, what we're going to do is we're then going to have a quiz all together. So in the next 25 minutes, we will try to solve a set of questions from this website. And after that, we will have a contest happening on the same website. And we will basically use the pieces of ideas that we've mentioned throughout this session to basically solve these puzzles. So let me open the link that I've sent to the Zoom link. All right. So I'm already logged into the system, but after you log in, if you use this link, you will be redirected to a page. And this website has lots of different programming questions that you could practice with. The collection that I have here are really basic bits and pieces that can help you start coding, but the website has also got further complicated puzzles to solve. So once you open the link, it gives you a description of what you need to do. So this very first link is a simple one. We just want to print hello world. So it's describing how you could print something in Python. It tells you that you don't have to read any input from the user. And what it expects you to do is to print hello world in stdout, which is basically printing it for the user. And it has given you an example of the output that it expects. And followed by the description, you can see a piece of text box that you can write whatever piece of code you want to have. And upon finishing, you can submit it and see if your code is going to solve the puzzle. So since this very first link is really very basic and it just wants you to print hello world, I'm going to show you how you can work with HackerRank using this example. So if you basically, so normally in the text box, normally in this text box, it might give you a template script that's going to help you write the code, especially for the set of beginner introductory examples. So it has already written print to let me know that I need to use the print function. So all I need to do is add the fact that I want to print hello world. And once I've wrote whatever I want, I can first test and see if my code is going to run correctly by hitting run code. And it tells me, okay, your code is running correctly. And finally, if I want to submit this problem, I hit the submit and it tells me that congratulations, you have solved this puzzle. So I encourage all of you to right now create an account on HackerRank if you have not already done it. And then, first of all, try this very example, the very simple example of printing hello world, which is the task 1 of the live coding session.